Good afternoon, everyone. I am Kath de la Cruz Pares from BSFT 1A. Today, I'm gonna report about the starch and starch product, especially in the properties of starch in gelatinization and gelation. The objective for today is to understand the mechanism of starch gelatinization and gelation, and to know the factors affecting the gelatinization and gelation of starch. First, what is starch? Starch, also known as amylum, is an important food product and biomaterial side worldwide for different purposes. It is the widely and common thickening agent used to thicken sauces and reduce sauce viscosity. Here are the starch properties, the gelatinization and gelation. First, what is gelatinization? Gelatinization is the process resulting in the irreversible loss of molecular order, resulting in an order-disorder phase transition within starch granules. And the second one is gelation. What is gelation? Gelation is a phenomenon of considerable importance during membrane formation, especially for the formation of the top layer. This is the gelatinization mechanism. As you can see in the figure 1, starch granules swell when heated in water at 50 degrees Celsius or above due to the entry of water molecules into the amorphous space. On heating, the starch granules absorb water and swell irreversibly. By providing continuous heating, the temperature increases and the starch granules absorb more and more water, start bumping each other and eventually rupture. The water molecules break the intermolecular bonds and the crystalline regions diffuse, resulting in the dissolution of the amylose chain. Thus, it results in the distortion of crystalline regions. And in figure 2, it shows the amylose chains separate into an amorphous form and leach into the surrounding water. The mixture attains the maximum viscosity as the amylose leach into the surrounding liquid, causes the mixture to thicken. Complete gelatinization occurs nearly at a temperature of 90 degrees Celsius. In gelation mechanism, as you can see in the figure 3, gelation is a phenomenon of considerable importance during membrane formation, especially for the formation of the top layer. The mechanism involved in gel formation are complex and may involve salt bonds between amino and carboxyl groups in the inside chain, and hydrogen bonding between peptide and disulfide cross-linkage that occur in the starch and water solution. What is meant by starch loss of bifringence during gelatinization? The starch gelatinization that is accompanied by the loss of bifringence has been interpreted in terms of a non-equilibrium melting process controlled by the plasticization of the amorphous region of starch. Why the starch that is almost amylopectin do not easily create gel? The branch amylopectin molecules cannot align as easily and thus give weaker hydrogen bonding and gel strength. On the other hand, viscosity is purely a function of molecular weight. The branch structure of amylopectin with all its attached chains yields a much larger molecule than amylose. In making a maja blanca, starch is being used, especially the corn starch. It helps to create a soft texture of maja. Also, it used as a thickening agent. Using cornstarch and water, gel can be made and varying the ratio will change the properties. When water is added in the starch and it is heated, some of the bonds between the glucose molecules break and the starch undergoes gelatinization. The factors that affect the gelatinization and gelation capacity of starch during the food preparation. The gelatinization temperature of starch depends upon the plant type and the amount of water present, pH, types, and concentration of salt, sugar, stirring, time, temperature, fats and protein in the recipe, as well as the starch derivatization technology are used. In pH, it has a great impact on the gelatinization of starch and thereby the viscosity of food products. The textual and sensory properties, the solubility, extractability, and denaturation of protein in the food products change with the pH level of water used in processing. A pH below 4 decreases the viscosity of the gelated starch. The second one is water. When starch is heated with water, the starch granules swell and burst, causing them to break down and release the glucose molecule into the water. The amount of water is needed to reach the complete gelatinization. And the other one is salt. It limits the starch gelatinization, so liberally salting pasta water reduces stickiness as it flavors the pasta. Starch thickens sauces. Thickening a sauce with flour or cornstarch reduces its flavor. And the other one is sugar. The presence of sugar decreases onset of gelatinization since sugar competes with starch in the availability of water. In baked products, sugar increases the starch gelatinization temperature, tipping air bubbles and delivering a light texture of cakes. And the other one is fats. Fat content had a prominent influence on starch gelatinization of the samples. Increasing the fat content significantly decreased the degree of starch gelatinization of the extrudates. Next is protein. When protein restricted starch swelling and enhanced recrystallization, whey protein increased the short range ordering in starch. Whey protein formed encapsulation and acted as a barrier towards starch digestibility. And stirring. Constant stirring helps in the uniform consistency and prevent lump formation, while too much agitation may cause premature rupturing of starch granules. And temperature. Starch gelatinizes when subjected to heat. Small starch granules require higher heat to gelatinize, while large starch granules require lower temperature. And the last one is time. Heating the mixture beyond the gelatinization temperature results in the lost viscosity. And those are the factors that affect the gelatinization and gelation capacity of starch during food preparation. That's all. Thank you.